Chapter 6 starts looking at the opposite of taking the derivative, which is going to be called integration. But first we want to define what the antiderivative is, and that's going to lead us to some basic rules of integration. And then lastly, we're going to have to solve some initial value problems. So what is the antiderivative? The opposite of taking the derivative. Well, we can read this definition. It may or may not make some sense to you. But let's take this function and let's take the derivative of this function. Of course, we'd take the 3 times the 1/3, and that would give us 1. Subtract 1 from the exponent. And then, of course, the derivative of the constant is going to be 0. So if I look at that, just going back to very basic rules, I have the derivative. So the antiderivative is the function that it came from. So we have the derivative and the antiderivative. However, I want you to think about, what if I changed this constant to, say, a positive 4? Would the derivative be any different? No, because the derivative of any constant that we might have here would be 0. And that's going to lead us to the discussion of why we need to have some arbitrary constant when we're looking at the antiderivative. The process of finding the antiderivatives is called antidifferentiation, which we don't use in the math world. We call it integration. And that integration, we have a symbol, which is the integral sign. It looks like an elongated S almost. And so it says the integral of a function is going to be its antiderivative plus some constant. Because if you took the derivative and went the other way, you would not know what constant you started out with. And so we have some other vocabulary talking again about that family of functions, meaning it could have many different constants. We have what's called the integrand, which is f of x. Then, of course, c is that constant of integration. On the computer, it kind of helps you out to not forget that plus c, because most of the time it'll have an answer blank and then it has a plus c. However, on the test, you have to remember to put your own plus c. So let's learn how to take the antiderivative of some simple functions. Again, you're going backwards from derivative. So how do you take the antiderivative of a constant? Well, it says if you take the integral of a constant, you take the constant and multiply it times x plus another constant. Let's just think about it. If I give you a function of 3x plus 1 and ask you to take the derivative, you're just going to get 3. So we're going backwards. So we have to put the x we came up with, but we don't know what constant could have been there. So that's the plus c. To take the integral of 2 and then this dx is that differential. It also tells us what variable we are integrating with respect to. You would just put the 2, which is the constant, the x, which is the variable, and then plus c. Pi is a constant, so we put the constant times x plus c. E is a constant. Yes, it is just a number. So e times x plus c. The square root of 52 is a constant times x plus c. And again, if you wanted to check your work and go backwards, if you took the derivative of 2x plus some constant, you would just get 2. The derivative of that is just pi. The derivative of that is just e. The derivative of that is just 52, because the derivative of all of those constants would be 0. So that's a pretty easy rule. The power rule comes from the power rule of the derivative. So if you remember, the power rule is that if we had a function like x to the 4th, we brought the power down in front and subtracted 1. So now we have to go the opposite way. So instead of multiplying, we've got division, and instead of subtraction, we've got addition. All right, so let's look at this. As we look at what this rule says, we need to take the variable, which is x, and raise it to one more power than what we started out with, so that'd be 2 plus 1, and then we need to multiply it by 1 over 2 plus 1. Let me write that a little bit better. So that's 1/3 x to the third power plus that all-important c. So we're going to add 1 to the exponent, which is -4, and we're going to multiply by the reciprocal of our new exponent. And don't forget to add plus c. Again, we're going to add 1 to 2/5, so that's 7/5, and then divide by our new exponent. But 1 divided by a fraction is going to cause you to take the reciprocal. On this next one, it's probably helpful if we rewrite this as a power. So that's x to the -1/2 dx. Again, bring it up to the top. So we change the sign, and the square root is 1/2. So as we integrate it, we add 1 to the -1/2 and get a positive 1/2. And the coefficient is going to be 1 divided by our new exponent, simplifying that fraction. So we've taken the antiderivative using the power rule. And again, if you wanted to go back and check, you could take the derivative of this, and you should end back with x squared. The derivative of this would be x to the -5th, and so forth. Okay, this next rule just talks about, just like we took the derivative, that you can split up the addition and subtraction and then take the derivative of that. Same thing with the integral, or the antiderivative. So this is going to be the integral of the first term plus the integral of the second term, since the last one is minus that. And then we would use each rule appropriately. So these would be the power rule, that's the constant rule. All right, so we add 1 to the exponent, and then we multiply by 1 over the new exponent. Then add 1 to the exponent, so -2 plus 1 is a -1. And then on the constant, we put that x, and since all of them added a big constant, we'll just combine that. And this is just going to be -1. And there's your antiderivative. Again, if we took the derivative of this, we should end up with the original function. Now we just learned that the derivative of e to the x is just e to the x. So if I'm going to go backwards, I'm going to get the same thing. But again, I've got to take into the account there could have been some constant there. Right? So the integral of e to the x is e to the x plus c. Here, if I have a constant out in front, you could rewrite that as 4 times the integral of e to the x dx. So that's just 4 e to the x plus c. Again, we take that constant, keep the e to the x plus c. Very easy. If you went back and tried to use the power rule on x to the -1, let's just look at that. The power rule said that you would add 1 to the exponent, but -1 plus 1 is 0, and then you would multiply by 1 divided by your new exponent. Hopefully you remember that you can't divide by 0, so this is not possible, so this is undefined. So they had to make a very special rule for x to the -1 power. And it leads us to x to the -1, which is the same as 1 over x, is that natural log of x function. Let's see if we can remember this. Remember, if f of x is the natural log of x, the derivative was 1 over x. So obviously the antiderivative is going backwards. And we need to put those absolute value signs. So this just follows the rule. This is the same as 1 over x. So this is the natural log of the absolute value of x plus that constant. This is exactly the same thing, just trying to write it a different way. Now here, this is 4 times the integral of 1 over x dx. So that would be 4 times the natural log of the absolute value of x plus c. Any constant, you can put it out in front of that integral sign, very much like we used the derivatives. Just keep in mind the power rule does not apply for that x to the negative 1 because you end up with that 0 in the denominator. So let's see if we can take a problem and apply those rules. Anytime you see a radical, just like we did in derivatives, we want to rewrite that as an exponent. So remember that's x squared, and to the 5th power that's going to go underneath, minus, and I'm going to take that constant of 7, and that's going to be 1 over x dx. So here we have the power rule, and here we have the natural log rule. All right, so we're going to add 1 to that, so that's 7/5. This is going to be the natural log. Don't forget that absolute value, and don't forget that big plus c. And then the last thing I would do would be to flip that. And in a little bit, I'll be skipping that step, just hopefully that you know that it's the reciprocal of the power. Okay, here, that looks kind of scary. We have a multiplication. We have something that's called the product rule, but we're not quite ready for that. Let's see if we can just simplify it by multiplying that out. So let's reduce those fractions. So that's going to be x squared minus 2 plus x to the negative 2 dx. Right now I can integrate each of those. I could write it out separately, but hopefully you're going to follow. That's going to be the power rule, constant rule, power rule. Right, so let's add 1 to the power. The coefficient's going to be the reciprocal of that power. The integral of a constant is the constant times x. Here's the power rule. Add 1, and then the reciprocal of that exponent. And hopefully you're thinking, ooh, she forgot her constant. You're right, but I'm going to get it right now. Plus c. So try to simplify your integral if you can. Same thing here. Okay, keep in mind that's an x to the half power. So what I can do is distribute, but instead of subtracting exponents, remember when you keep the base, you're going to add the exponents. So 1/2 plus 4 is 9/2. That's to the 1st power, plus a half is 3/2. And then I just have 1 times that. So as I take the integral of all of that, those are all the power rule. Okay, so let's add 1 to 9/2. That's going to be 11/2. In front is the reciprocal of that power. Adding 1 to 3/2 is 5/2. Again, the reciprocal. Adding 1 to a half is 3/2. The reciprocal, plus that constant of integration. So now they're going to ask us to find a function given the derivative of that function. And then they're also going to give us some other values so we can actually find the exact function. Remember, when we take the integral, we have that plus c. So this information is going to help us determine what that constant is. But let's get back to that we are asked to find f when we're given the derivative. So we need to take the antiderivative of the given function. So that would be the integral of this function with respect to x. That's what that dx is. All right. So again, we could separate this. Remember, you can always put the constants out in front of the integral if that helps you. And all this is going to be the power rule. So this is going to be 3 times. Add 1 to the power, and the coefficient is going to be the reciprocal of that power. Add 1 to the power. Remember, there's already a 1 there, so that's going to be a 2 times the reciprocal of that power. Then if you have a constant, you just put an x plus c. So let's clean that up. We have x cubed plus 2x squared minus x plus c. So that's going to be f of x so far, but we need to know what c is. And that's where this information comes from. That says when x is 2, y is 9. In other words, when x is 2, f of x is going to be 9. All right? So that says this is 9 when x is 2. And that way we can do the arithmetic that's going to allow us to solve for c. So my function would be x cubed plus 2x squared minus x minus 5. And that's the specific function that would meet those initial values when x is 2, y is 9. Let's do that again. Again, we need to find f by taking the antiderivative. So I want to take the integral of 1 plus 1 over x squared with respect to x. So I'm going to rewrite that as 1 plus 1 dx, and I probably forgot that in the last one. That just helps me remember that it should be there. And then I'm going to rewrite that as x to the negative 2 dx. So that's a constant here, so I just put the x. That's my power rule, so I add 1 to the power, and then that's the reciprocal of that power plus my constant. So my function is x minus 1 over x plus c. That can go in the denominator. And then I take my initial values when x is 1, y is 2. So we have 2, 1 minus 1 is 0, plus c, so c must be 2. And so my function, you can check your work by a couple of ways. You can take the derivative of this and you should get back there. But you also have to check your initial values. When you plug in 1, do you get 2? Right? These last two problems ask us to find the function f, given that the slope of the tangent line to the graph of f at any point, that would be the derivative, is given, and they're giving you through the point. This is exactly the same thing we just did. You want to find f by taking the antiderivative, right? So I want to leave that constant there, add 1 to the exponent, so that's a half, and then multiply by the reciprocal of that, that's 2, plus my constant. So my function is this. Then I need to plug those values in. This is x, this is y, so the square root of 2 equals, now remember that's a square root sign, so we have the square root of x, and x is also 2, plus c. So c in this case is 0, so my function is the square root of x. I'm going back here. The half power is the same as the square root, and c was 0. Okay, so one more time. We want to take the integral of 2 over x, and I could write that as 2 to the x minus 1 plus 1. Now, this is not the power rule. That's that natural log. So that's 2 times the natural log of the absolute value of x. Then the integral of a constant is just x, plus that constant that we don't know. Then we come back up here and let x be 1, y is 2. Okay, if you wanted to punch this in on the calculator, the natural log of 1 is 0 times 2. That's still going to be 0. So we have 2 equals 0 plus 1 plus c. I think if we do the math, if we subtract 1, we get c is 1. So if I come back up here, the function I'm looking for, so the antiderivative, or the integral, is really not so bad if you kind of remember your derivative rules. They're just going backwards.